So I'll just share the subject names in this semester, third semester as per TCS curriculum. Okay, formal language and automata theory, first subject. Formal language and automata theory. Okay, second subject which I'll be handling. Second subject, computer organization and architecture. This is similar to the second semester architecture subject. Vishnu Shakti ma'am will be there. If there are any topics which is not handled in the second semester, she'll be coming and taking the class. And third, we have got as object oriented programming, which is there in your current curriculum also. It is, we have requested for a change of language as Java, so it will be correlated with an university syllabus, so nothing is to be taken extra. Next, we have got computational statistics plus lab. Okay, this will be handled by Ganapati sir. And next we have software engineering. Instead of software engineering, we are going to handle database management system in this semester. All of you have got it? Next is financial management. This will be handled by Chidambaramani sir. TBMS will be handled by Sri Lakshmi ma'am. So financial management. These are the subjects in the TCS curriculum. Have you all got it? In third semester, what are all the subjects available? And when you go for TCS curriculum subjects, formal automata, it comes in our fifth semester in your university curriculum. I'll just give introduction because it's an important paper, so we may not have much time in an university curriculum. So I'll be handling some basic concepts in this TCS class. Next, financial management also we have in seventh semester. So we'll just give some basics in those. Okay, so most positively in this semester, computational statistics is also being covered in your university curriculum in the further semesters. Okay, so we'll just give some introduction alone, we'll give it. So everything is there in your university curriculum, no subject is left out. Are you all clear, dears? Are you all clear? Students, are you all clear? Any of you just respond. So today we are going to just give a what all the subjects are there in TCS curriculum. Have you all got it? Priyadarshini, Roshni, any one of you unmute and speak da. Yes, okay.
Yes, ma'am.
Okay, da.
Yes,
So
ma'am.
today I am going to take the basic concepts in formal languages and automata theory. Okay, so the name itself gives you formal language. So you all know when you have a computer, when we are communicating to the computer, it is responding to us. So in some language, we are trying to communicate to the computer or to the processors. So how it is been recognizing? You all know there will be some registers where we are going to store a data. So in what way the languages are being specified? So that is what it is. This subject is going to deal with. I'll just give the introduction to the subject and some basic terms in the subject. Shall we proceed, Da? Shall we proceed?
Yes, ma'am.
Okay.
Yes, ma'am.
So first we'll give you just introduction to automata. So have you come across with this term automata? Da? If it is auto, it is nothing but you might have come across. Have you come across with this term automata? You may not be, I think so. Automata is nothing but it's like a machine. It is like a machine where you have, for example, whenever you take any device, let it by your laptop or your mobile device or whatever it might be, can you just say me what are all the different states we have in any device? Can you just tell me? In any device, what are all the two states we have? Any device, any of, please respond, please don't make me to feel bad. Please tell in any device, can you just tell me what are all the two states available? Or for you, individual person, can you just tell me what are all the states available for you? In which state are you all now? All are in sleepy state, are all in idle state, or you all are in active state? Tell me
Active state,
whichever
madam.
concept. Active state. Okay, so automata is nothing but it's like a machine. So when you take, we all have some states where we might be in an active state or in an idle state or in a sleepy state, whatever might be the case. When you go for a machine, you can say it is turn on off. For example, you have a switch where that switch, if it is going to have some connection represented, it will be in a turn on mode, otherwise it will be in a turn off state. Okay, then you go for automata. Why this automata comes into picture, where it is being used. For example, you all have done programming languages in the Google Colab in the last year. When you are typing class, the name of the class, so how this has been recognized, how it has been accepted by the compiler, how it has been processed, you all might have a question. So there might be some background work being done in the compiler. Okay, for that everything we have a base as automata. What it will do, it seems, the machine will be in particular state. For example, let us consider I want to accept a keyword if. So your automata machine will start in the start state, get the first character I, it will go to a next state. In the next state it is waiting for f. If it reads f, it will go for the final state returning the keyword if. For example, if it is again if, after if I'm getting a space, again I'm reading e, it will go for if else, it goes on. So automata is being used in your processors or in your compilers, where it is going to read the each and every character, try to recognize what is the string given, and accordingly your states are being changed and it will return the exact value. So when you go for compiler, I think this I might have specified in some initial classes in your first year. Compiler will have some phases I've said. So your automata is a machine which is used in the first phase of your compiler, which is lexical analyzer. If you have written in Python class, the name of the class, then it should have an indentation, def, the name of the class, whatever it is. So it will have, if it is def, it should have a space followed by a keyword where you are defining a method. Or if it is a if function, if condition, then you have to have some set of statements, else you can have some set of. So likewise you are trying to give some configurations. So that is being specified in the first phase, which is nothing but lexical analyzer, where your input text, whatever we are giving, it will be separated and specified as tokens. We'll term it as tokens. For that we are using this automata. Then digital circuits, if the circuit is in this condition, it is turned on, and if it is reaching to this condition, another input it has to take, and it has to move on to these two different states. So based on the input, your state might be varying, and might be giving different outputs. For example, NAND gate, NOR gate, if 0 is one input, next input is 0, you will give the output as 0 in case of AND gate. In case of NAND gate, it should be 1. So in that case also, this automata comes into picture. Okay, and similarly, if I want to collect various web pages, find out whether this particular word is available in that, for searching and finding whether this particular phrase is available. How will I identify a word? For example, I'm searching for a word and. How will I use this automata? You have to start in the initial state, get the letter A. Next, after that, it is waiting for N. If it has got N, it is waiting for D. If it has got D, it should stop. It return A and D. So it will search in the whole web pages, find out wherever A and D comes into picture. There also this automata comes into picture. Similarly, when you go for a communication protocol, you might be in one state waiting for an input. If your input has got some process to be done, you will go to the active state, or you might be staying in the same idle state. So it depends upon all this. All these are examples where automata comes into picture. Have you all got the idea, Dakane? What for this automata is there? It is a finite state machine, just a machine. Have a consideration of turn on, turn off of a switch. Same way your automata is going to work. It will be in one state, read an input, it will be taken to another state, read an input, taken into another state. Suppose reading all the inputs, if that is acceptable, it will go to the final state. Are you all getting that? Shall I go for the next slide?
Yes, ma'am.
Okay.
Yes, ma'am.
So now, before moving into what is automata, we have seen. Now, in this automata, I have said no, A and D it is going to accept, or if else it's going to accept. So there are some variables which is going to be read as an input in your automata. So we have some basic terms which you should know before moving into automata. First is termed as alphabets. So when you go for alphabet, it is a finite non-empty set of symbols. Symbols, it is a symbol. You don't consider alphabet, don't consider only A to Z, don't have that. It is alphabet is a different specification in automata. Whichever inputs it can consider, everything will be taken as an alphabet in that particular automata. It is going to be a non-empty set of symbols. What all can be taken as an alphabet? Either a binary number, either 0 or 1. It will be taken as binary alphabet. Or you can have set of all lowercase letters. Or you can go for set of all ASCII characters. So these are all some examples of alphabets. You might have a question, ma'am, can't I use the uppercase character into an alphabet? No, we are not going to use uppercase characters here as an alphabet. Whenever you're writing any string, it should be in lowercase only. Uppercase, we will be using it to represent. For example, A, B, C, I'm giving as a string now. If I want to narrate the string with a name now, in that case, I'll use uppercase letter to narrate the name for that string, which is a collection of an alphabet. So alphabet is a collection of a symbol. Either it can be a binary symbols, 0 or 1, it will be termed as binary alphabet, or it can be A to Z, A, B, C, D, E, F, G, H, whatever it might be, or any ASCII characters. Are you all getting what is an alphabet, GS? Shall I go for the next? Have you all got what is an alphabet? Are you all taking running notes, dears? Please try to have a separate thing which you might be continuing in your 5th semester with the same subject in the Anna-University curriculum. Shall I go for the next slide?
Yes, ma'am.
Only Gautam is listening the class. Next is string. Next base term is strings. A string is nothing but it's a sequence of symbols. I have said no. Either alphabet is nothing but either it is going to be having 0 or 1. Or A, B, C, D, E, F, G, H. Each and every symbol is termed as an alphabet. So it's a collection of symbols. If I say it's your string is going to have a binary alphabet, now your string should have combinations of zeros and ones. If I say alphabet is going to be a set of lowercase characters, letters, now a string should have A, B, C, D, E, F all to be collected together to form a string. So it is a finite sequence of symbols chosen from any alphabet. An example I've given, 0, 1, 0, 1, 1 is a string which is chosen from the binary alphabet. A, B, C, D, E. It's another string which is chosen from the lowercase, that is alphabet, alpha characters. A, B, C, D is an example. Can you just tell me any other example? Anything. So binary alphabet, if it consists, it's a string of collection of zeros and ones. If it is based on lowercase characters from alpha characters, it is A, B, C, D. It is a collection of those characters. Got it? What is a string? Students, have you got it? What is a string?
Yes, ma'am.
Yes, ma'am.
Okay. Next, we have got an empty string. So whenever I have a string, it should have a collection of symbols. I can also have an empty string. It means that I don't have any alphabet to be represented. It is an empty. So it will be denoted by, it is like epsilon duck, and I'm not able to get that symbol exactly. So I have placed over here a different symbol. It is like epsilon. I'll just place it in the thing. It is nothing but symbol. How you have to represent this is your empty string. Are you all getting what I have written? Okay, got it, yes?
Yes,
And
ma'am.
for alphabet, the indication is like this. For alphabet, when I represent any alphabet, you have to write like this. Suppose if it is a
Ma'am,
binary
sigma,
alphabet,
sigma, ma'am, that's
which is
sigma
that?
alphabet,
This,
ma'am.
yada, yada.
Okay, ma'am.
I'm not able to get it from the insert symbol, so I didn't make it. Suppose if it is 0, 1, na, you are telling it's a binary alphabet which is going to have a symbol which can be either 0 or 1. This is how it will be represented. Are you getting it? If I'm going to represent an alphabet with characters A to Z, na, A, B, dot, 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 Z. So it is going to have a lowercase characters A to Z. This is an alphabet. So this is an empty string. Got it? Got it? String can be represented by capital S, or any other uppercase characters can be used to represent a string. Okay. Next, to find a length of a string. How will you find the length of a string? Whatever we have done in our programming languages, if you want to find a length of any variable, you will be doing it. No? So it is number of symbols whichever is available in the string. Length of empty string, what it might be actually, empty string is nothing but which we don't have any symbols or any alphabet. So length of empty string is nothing but 0. What is the length of a string ABC? What is the length of the string ABC? Da? What is the
3,
length?
ma'am.
3.
2, ma'am.
Okay. 3, 2. Hey, ABC.
Ma'am, 0, 1, 2, not
Day.
like that.
Length of empty string is 0, I have said. How come
Okay.
length of a string will be 2?
Oh, okay, ma'am. Okay.
They
I
don't
confused with
confused with
indexing,
the
ma'am. Sorry,
indexing.
ma'am.
The indexing is different here. The length of an empty string is 0. How many symbols are there in the string? A, B, C. So 3 characters are there. 3 symbols are there. So it is an alphabetic based on the alpha characters. So length of the string will be 3. Next. So what are all the terms we have seen till now? Can any of you just tell me? What are all the terms we have seen till now? What are all the terms we have seen till now? Any one of you just say me that. These are all the base for your automata theory. No one is listening the class?
String, empty string, alphabets.
Alphabets, strings, empty string, length of a string. Okay, so these are all the terms we have seen now. Now, alphabet is nothing but a set of symbols. Set of symbols. Okay, it is not going to have a collection of symbols as each and every symbol will be an alphabet. So set of symbols can be termed as an alphabet. If it has got set of zeros and ones, it will be termed as a binary alphabet. If it is going to have a lowercase character set, it is going to be termed as alphabet based on alpha characters. Then if it is going to be have a ASCII characters, then it will be termed as ASCII based alphabets. String is nothing but where those alphabets are being specified, those symbols are being specified in some sequence and you are trying to represent that as a string. Language is nothing but collection of strings. So now are you able to find out that an alphabet is the base, then I form a string, collection of strings forms languages. Are you all getting it? So here that whatever symbol I've used there, alphabet, that I represent it as EDA, don't get confused. That is what symbol. Okay, so this alphabet star is nothing but it is a collection of strings. Star, this represent, you have to represent here as a closure. We'll term it as a star closure, where it might have 0 string or any number of symbols being attached in a string to form a language. So language is nothing but collection of strings. Are you able to get it, Takane? First we have alphabet, then strings, then languages. Okay, you all know in the string we have got 0 also as a length. So we are representing it as star closure, where it is going to have elements 0 or more elements. 0 or more elements will be represented by the star closure. Got it? So these are all the types of languages we have in our automata theory. You might be asking, ma'am, what is this language? We have come across with C language, C++, Java, Python. What is this, ma'am? You might be having a question. These are all the languages which is being used in your automata theory. This is what our units are going to cover. First is regular language. Your first unit will cover regular language. Second unit will be context-free language. Third unit or fourth unit might be recursive, recursively enumerable, non-recursively enumerable. Don't get confused now. As of now, don't get confused. Just note down there are 5 languages which are being used in the automata theory. Okay, so initially you will not be able to find out what is regular language, what is context free. Don't get confused, just note it down. Finite automata I have said, no, in that first example is nothing but first variation in automata is finite automata, which is going to be used to accept regular language. Okay, that is what. Have you all noted down these terms? Just note it down. Nothing to worry about it. Everything will be easy. Whenever I take class, you'll be able to understand what is that. Are you all getting what is regular? Just note it down, those 5 languages. If you said okay, I'll proceed to the next. Are you all taking running notes down for this automata?
Yes, ma'am.
Okay, yes. Is it interesting, this subject? It will
Yes,
be
ma'am.
I like this subject actually. First, this is the subject which is allotted to me when I've started my career here in RMD. Okay. Shall I go for the next slide? Da? Regular language, context-free language, recursive language, recursively enumerable language, non-recursively enumerable language. These are the languages which is being accepted by the automatas. If you say okay, I'll go for the next slide.
Okay, ma'am.
Okay. So next is just an example of finite automata. I have said no automata. In that automata, we are going to see first thing. Initially, we have to see what is meant by an alphabet, string, languages, all that we have seen. Then we are going to start with the first topic, which is finite automata. Automata is nothing but it's a machine, I have said, where it is going to accept some set of inputs. It is going to move to from one state to the other state. That is what I've said. Finally, it will reach the final state. Can you just tell me what is finite automata? Automata, I've said some applications where it is going to read some characters and it is going to move from one state to the other state. Can you just tell me what is mean by finite? Can anyone of you just what is finite?
Countable, ma'am.
Yes, if whatever the number of states, it because what we have said automata, it is going to read it, move from one state to the other state. Whereas finite automata states that your number of states is in finite count. That is, number of states which is going to be there in that automata design is going to be limited, and it is going to be a countable one. That is termed as finite automata. Here, if you see here, this is an automata which is accepting the binary alphabet. Correct, Ada? It is a automata which is going to accept binary alphabet, and whenever the string whichever is going to be accepted by this automata is going to be a collection of binary alphabets. So let us consider, whenever you draw this finite automata, you have to represent in circles. The states will be represented as circles, and which state is going to be the start state will be indicated by the start arrow mark. Okay, so states will be represented by circle, which is going to be the start state will be represented by this simple arrow mark, which will not be linked to any other states. Next, double circle, there is a circle here no in Q3. This is nothing but accepting state or final state. That is nothing but accepting state or final state. Shall I explain this diagram? I think this is explainable to you. It is in Q0 state. Accepting the input Q1, it is moving to Q0. If the input is 0, it is going to Q2 or Q1 or Q3. From Q1, if it is 1, it is going to Q2 or Q3. From Q2, on reading 1, it is coming to the final state. Can you just tell me the strings which is accepted by this automata? Accepted in the sense it should start from start state, go to any of the states, finally it should reach the final state. Tell me the strings which is acceptable by this automata. There are so many strings acceptable. Any one string, can anyone of you tell, which is acceptable by this automata? Students got this or not? Students, have you got this or not, this diagram? If you say only, it will be perfect for me to understand whether you are able to follow or not.
1011, ma'am.
1011 is accepted. 1, 0. Where you gone? 1 here.
Q naught,
Q
Q1,
naught,
Q2, Q3.
Q naught, Q1.
Q1, Q2,
Oh,
Q3,
Q2,
ma'am.
Q3. Okay, 1011. Okay, that is also acceptable. 10 is also acceptable. 0 is also acceptable. 01 is also acceptable. So all these are the possible cases in this finite automata. Okay, just have this diagram. Have you finished drawing this diagram da? Which is start state, what is a state, what is a final state. So this is an automata for accepting some possible strings which is in the alphabets of binary set. Okay, this is just an example. I'm saying how an automata you have to draw. It should have a collection of states. Okay, shall I go for the next slide?
Yes, ma'am.
Okay, so when you, before that we have drawn diagrammatically, the same thing has to be represented in a notation, a mathematical notation. So you can say when you go for this DFA, you might have a question DFA. I'll just go for the. So when you go for finite automata, we have seen finite automata, correct? So when you go for finite automata, there is a two types of finite automata. One is termed as DFA, other one is termed as NFA. What is DFA? What is DFA? DFA. FA, you know, it is finite automata. D represents deterministic. D represents deterministic finite automata. D represents deterministic finite automata. Next, we have got NFA, where N represents non-deterministic. Non-deterministic. Deterministic, non-deterministic. Have you noted down these two terms, Da? I'll just say you the difference. What is deterministic and what is non-deterministic? Have you finished taking these two terms, deterministic and non-deterministic?
Yes, ma'am.
Okay. When you say deterministic, so this is my start state. Let us consider Q naught. Q is a state. So Q naught, first state we are representing as Q naught. Then let us consider on reading 0, it is Q1. On reading 1, it is going to Q2. Let us consider, I'll stop here. So from Q naught, on reading 0, it is going to only one state Q1. From Q1, on reading 1, it is going to Q2. Let us consider if I have, if it is 1, let us consider it is going to Q naught. Let this is be the case. Or if it is 0, it is going to Q1. This is going to be the case. Let us consider. This I am representing it as DFA because in binary alphabet, what are all the two alphabets possible, Takane? The inputs which it can read? It is going to be either 0 or 1. Correct? Yes or not, da?
Yes, ma'am.
Okay. So if I can go for either reading 0 or 1. If in Q naught, if it is 0, I have only one state as an output state. It is determined. I don't have so many options to go. So this is termed as deterministic. Whereas NFA, I'll draw it. NFA. Okay. From Q naught, let us consider I have 1. Similarly, I have 1. I have 0. Don't think that if I get another different arrow, it is, don't confuse with that. Okay. Q2. Then 0, I have Q3. Let it be final state. Q2, 1. Okay. Don't go anywhere. We are just comparing with Q naught alone. Okay. So when Q naught is going to be the state, if it is reading 1, either it can go for Q naught or Q1. So there are two paths which is possible. It can choose it from any of this. For example, if you take the keyword, then. And if you take the keyword the, so in automata, if I'm designing, it is waiting for the character T, it is waiting for the next character H, it is waiting for the third character E. If it gets fourth character, it is then, otherwise it is the. So you have options to be chosen. That is termed as non-deterministic. You cannot have a fixed path. It can go choose from any paths based on the finally only you'll be able to know which you have come across. Are you getting it? What is the difference between DFA and NFA, DS? Are you getting that?
Yes, ma'am.
Okay, only Gautam is listening. Huh? Students, please, these are all important subjects. It will be tough actually. For that only because it is there in the university syllabus, then also I am taking. So this is deterministic or non-deterministic. Deterministic or non-deterministic. Bindu Priya, can you tell me whether it is deterministic or non-deterministic?
Non-deterministic.
Very good, dear. Srinidhi, can you just tell me if this is deterministic or non-deterministic? Srinidhi Kamakshi or Srinidhi, any of you? Srinidhi Kamakshi, tell me whether this is deterministic or non-deterministic.
Yes, ma'am.
Tell me this is deterministic or non-deterministic, Srinidhi. What I've drawn in the red color. DFA or NFA? Srinidhi Kamakshi. Srinidhi, where are you?
Yes, ma'am.
Yes, ma'am. Tell which is this is DFA or NFA, da? Srinidhi, you didn't understand? Srinidhi.
I think so. It's DFA.
Yes, da. It's DFA. When it is a DFA for any state, for a particular input, it should have only one output state. Then it is termed as DFA. Whereas in case of NFA, for a particular state, for a particular input, there will be number of output states. Then it will be termed as NFA. Are you getting that? Are you getting what was NFA and DFA? Okay. So now this is just a thing. Initially, you may not be finding it. So this I can take it in the next class. So this is DFA, which will have some tuple representation. Whereas Q is nothing but finite set of states. In our diagram, I have drawn Q0, Q1, Q2, Q3. So all will be named as capital Q. This is alphabet symbol. And this is a transition. From Q0 on reading the input 0, it is going to Q1. So that transition we are representing it as this delta symbol. Q0, initial state, then final state. So DFA will have 5 tuple. One is number of states, alphabets, transition, initial state, final state. So your DFA will be represented by a character capital M. Got it, da? So have you got some basics in this subject? I think with this we'll wind up the session. Have you all got some basics? How an automata, what for this automata is there, what for we are going to study, what are all the base terms which is used in automata, alphabet, symbols, alphabets, strings, empty string, languages, then what are all the different languages. So those are all the languages which we are going to accept on designing some automata. First automata we have started with finite automata. Two types in finite, DFA, NFA. When for a particular inputs, a particular state, on reading an input, if it is a determined output state, it will be termed as DFA. From a state, on reading an input, if there are more number of options of states, it will be termed as non-deterministic. Are you all getting the base concepts of automata theory, da? What for
Yes,
you are
ma'am.
reading the subject?
Ma'am.
It is used in
Yes,
whatever
ma'am.
you are doing now. You are writing your Python language. You are writing C program. All that base background is nothing but this finite automata which is being designed in your compiler. Okay. Okay, dears. Thank you da.
Thank you,
Okay.
ma'am.
Okay da. Okay da. Thank you, dears. Thank you all. Just do your roll call and then leave the class. Just do the roll call and then leave the class. Whomever has left, ask them to do the roll call and then leave the class. Do the roll call and then leave the class, dears. Nikita and Dinesh, not there in the class. Do the roll call and then leave. Thank you, students. Thank you. Bye. Marla, Nikita, are you not there in the class?